at first. So we're going to go a little bit slower today. And I know I did get the lecture out a little bit later than I wanted to yesterday. So we'll take this a little bit slower. And then I will also, instead of doing a larger example, we'll look at some smaller practice problems in Ed today. And I will answer all of the questions that I can that you have about promises. So let me go ahead and share my screen here. Okie dokie. So as I said, asynchronous programming and promises. We are going to have CP2. CP2 is due today. That's right. Yep. By 11, and then homework 2, which has been released, is going to be due next Wednesday by 11 p.m. And I do want to emphasize to everybody that please get started on homework 2 as early as possible. At the very least today, just go ahead and read it. Read the spec, and so you can get a sense of how long it might take you to complete it. It is significantly larger than homework 1, so you're going to want to allocate a good amount of time to be able to do it. So at least today, go through, read it, and see what's in it. So I've already posted the videos on this lecture material, so I'll go through it quicker than I did in the videos, but I will go a little bit slower just because I think it's good to see promises frequently, often, as many times as possible, because they can be very, very confusing. So, but first, asynchronous programming. What is asynchronous programming? Well, synchronous programming, I think it's easiest to compare to that first, is where we execute lines of code one right after the other in the order that they appear in our code. Asynchronous is where we can have blocks of code executing at the same time or alongside other code. They can start at different periods of time. This shows more of a parallel model of code execution, whereas JavaScript does have some parallel capabilities, but in our browser, the main thread that we're working on is more concurrent. But this is sort of the way it feels in our JavaScript programs when we use functions like add-event-listener and set-timeout. It seems like we're executing code alongside other code or at the same time. And so this is exactly what we see in our normal JavaScript programs, right? So we have add-event-listener calling click handler, and that happens at some point in the future whenever the user clicks. But these 3 lines here, when we call the init function, are executed synchronously. So our code that we've written this far has this combination of synchronously executed code and asynchronous code. And so again, we also see that with set timeout. And you might be familiar with something like this in other programming languages where you loop using a while loop until something happens, right? You can't really do this in JavaScript. And this is sort of a what if we could listen for a click on a button using this kind of syntax, this strategy, right? Where we access our button and we wait until some clicked property is true, then execute another line of code, and then wait for the next thing to happen. Can't do it in JavaScript. It sort of defeats the purpose of event-driven programming or asynchronous programming. But the logic is pretty easy to follow, right? You know exactly what's going to happen. You're going to wait, execute something, wait again, execute something. And that is nice to see it. So, what if we could still use our asynchronous code, but make it feel a little bit more synchronous? And that's why we started talking about promises in the first place. We already have add-event-listener and set timeout, which allow us to deal with asynchronous events and uncertainty in our code about when things are going to happen. So you might be wondering, why do we need a third tool here to handle, asynchronous events? And the way we sort of motivated this in the lecture videos is that what if you wanted something to happen in a series of steps where one step can't happen until the previous step finishes, right? It's dependent upon the previous step. So the analogy was you're out for pizza and you have to follow these steps. These are naturally occurring logically, and you don't do one before the other. And the previous step has to finish before you can move on to the next step. And executing that in code with what we know so far about add event listener and set timeout can get you into this really nasty chain of callbacks, where you set a timeout and you pass in your callback. And so after a certain period of time, we execute the function we passed into our set timeout, and then that executes some other code, right? But then that takes a certain amount of time to execute. So we do another set timeout, and we just keep nesting these. And for those of you that were lucky enough to be able to actually watch the videos, lecture videos yesterday or earlier today, we saw this example here where I tried to recreate that in our code with add event listener and set timeout. And so what this was doing, when I would click this, I would wait a certain amount of time, then I would add a click listener to this, wait a certain amount of time, add a click listener to this. And the code ended up looking almost exactly like what we have here on this slide. So this is a real issue. This isn't, totally made up. We can actually get into this kind of callback place that we don't want to be in. And so wouldn't it be nice if we could actually do these steps in a more synchronous seeming fashion? And with promises, we can make something that looks like this, where we wait for some. And once we get the pizza, then we can eat it, and then we can pay for it. And so what if we could have this same structure in our code? It would be much, much nicer and cleaner, and we wouldn't have to deal with these nested callbacks nearly as much. And so that's why we are using promises, because they allow us to handle our code much more nicely in a synchronous manner. And you might say, well, add event listener is kind of doing the same thing, right? I'm listening for some event, and when that occurs, then I execute asynchronous code. But again, you don't get necessarily this nice synchronous flow with add event listener. And there are some additional things that promises provide that add event listener doesn't. So for example, promises guarantee that something will happen. So if we had add event listener, we listen for a click, then we would execute code. So we guaranteed basically that something would happen when we clicked, but we didn't say, okay, what happens if the user never clicks or they don't click within a certain period of time? That's where promises differ. So inherently, we want a promise to either resolve or reject. And while when it's not in either of these states, when we first make a promise, it's pending. So you can think if we were to make a promise for a click on a button, it would be pending. And if it's clicked, this gets resolved. But if in a certain amount of time the button wasn't clicked, then we would reject this promise. And we can actually execute code in response to either of these state changes. So if our promise goes from pending to resolve, we can execute some code, say like the button was clicked, do something in response, or after like 10 seconds, if the button's not clicked, we reject this promise and we execute a different line of code. So that's one of the main differences. And then we can also have multiple things happen with promises. And you can do that without event listener, right? But you have to add a separate event listener each time. But promises naturally allow you to chain the response functions, basically, that you want called in response to the previous thing that happened. So it naturally allows you to order steps like you might in your own life, but in code. And so that's really, really nice here. And so, if you return to the example about the pizzeria sitting down, ordering food, when the waiter leaves your table after you've ordered, he says, I promise I'm going to return to your table. While you're waiting for him to return, the status of this promise is pending. If he comes back with the pizza, we fulfill the promise and we're going to eat it. And if he comes back without a pizza, we reject this promise, and then we're going to do something else, probably like go to a new restaurant. And so how do we create a promise in our code? Well, promises are actually, basically, you can think of it as a class in JavaScript, and we can use the promise constructor to create a new promise object, and we pass in this executor function, and I'm going to say a little bit more about this. But then once we have our promise object, we can call its then function and pass in functions, response functions that we want to occur when we go from pending to either resolved, or from pending to resolved, or from pending to rejected. And so the first function we would pass into then would be the function that we want called when the promise resolves, and the second function would be when it rejects. Now, there's a shortcut, like a shorthand function for this on then on rejected, and it's the catch. So instead of doing on fulfilled, on rejected, we can actually just do dot then on fulfilled and then chain a catch at the end of our chain of then calls like we have here. So that makes it much, much easier. And this catch will actually not only catch rejected promises, but it will also catch any errors that are thrown in our code. So we will, you can see the chat. I'm so sorry. I'm trying to get it out of the way here so I can see it. Let me make my screen a little bit smaller here. Sorry. Still want to be able to see the chat here, so hopefully this is good. And then, right, so I was talking about this catch block. And so this allows us to, if we put it at the end of a chain of then calls, we can catch any errors or any rejected promises this way. And now what is this executor function that we pass into the promise constructor? Well, this is the logic that determines when or if our promise that we've created resolves, fulfills, or rejects, right? So in our pizza example here, if I got a pizza from the waiter, then my promise is resolved. And if I don't get a pizza, then this promise is rejected, okay? And these resolve and reject functions are actually passed in by the browser, by the promise object. It is built in code. You don't have to write those functions. They are passed into the executor function that you, as the programmer, write to determine when a promise is resolved or rejected. And when we call resolve in our executor function, that is the point at which we execute the functions that we've passed in to the then function, right? And if we call reject, that is when we call the function that we've passed into our catch calls, okay? So let's see a really quick example here. And I'm going to continue this pizza example. And what we're going to do here is create a new promise. And the terms for this promise, like the logic for when it resolves, is simply, it's always going to resolve, but it's going to resolve in 5 seconds. I'm going to do a set timeout here. After 5 seconds, I'm going to call the resolve function. This promise will resolve. And once it does, then I'm going to call, I will execute this function, or this function will be executed that I passed into the then function, right? So I'm just going to copy this and just put this into the console here. And that is some large code. And you'll see here that after 5 seconds, we printed out eating pizza. But you'll also notice that we've immediately printed out making our pizza. What this tells you, or you should know, is that our executor function gets executed immediately when we create a new promise, right? So this console log statement executed immediately. Then we had the set timeout. And after 5 seconds, this resolved the promise, and we called or executed this function here that we passed in to the then method. And here we printed out a promise. And this was, you can see here that the status of this promise is now resolved, and it resolved after 5 seconds. Okay, there are a bunch more examples here. I'm trying to think if I want to go through these. Okay, you know what? I will say one more here. Let me pick the one that I would like to do. We'll look at these two. So not only can I just resolve a promise, we can pass in a variable into the resolve. We can give it an argument. And so in this case, I can pass in to resolve, here's your pizza. And this will actually get passed into the function that I have here in the then call, right? So it's going to be the same exact thing here. And you'll see that this is just going to print out the message that I had passed into resolve, right? And what I can actually do is I can chain these then calls, right? And I can continue, and I can pass my value that I have given to resolve, and I can keep passing that down to each function that I have in my then chain, right? So in this case here, if we go back one slide, we have resolve passing in, here's your pizza. And then here, my eat function is just going to return that same value, plus now it's gone. So I'm going to copy this, paste it in, hit enter. And the very last thing I should do is console log. And you can see here that eat took the value that I passed from the order executor, which was simply, here's your pizza, right? And then I appended this extra string to it. And then I return it from my eat function here, and that gets passed into this next function that I called, or that I chained using then. And then finally, that value got printed out to the console. And so I can continuously do this with my with these then calls. I can chain them. I can do something with the value that I got back, process it in some way, and give it to the next function to do something else to that value. So you can almost think of this pipeline where I'm slowly processing this value in steps. And one of the really powerful things about promises is not only can I execute something immediately after my original promise has been called, like I saw before, right? So we had the order pizza, it resolved after 5 seconds, and then I immediately logged out to the console, or I immediately returned a value that was logged out to the console. But these functions here that I pass into then, like eat in this example, can return other promises. And what this does is it pauses the execution of this then chain until the previous promise is resolved, right? So in this case, I'm not going to call or log out, or I won't call eat, right? I won't return this function until my order pizza promise resolves. And then I will have to wait until the eat promise resolves until I log out to the console. And so we can take a look at this again. Let's see if I can get, I need my order executor, and then I'm just going to copy this here and put this in the console. And you'll see we wait 5 seconds, and then we're going to print out eating our pizza, which was the get executor, and we waited another 3 seconds before we printed out paying the bill. And so you can see in this sense, we can have a whole dependent series of steps and sort of make them look synchronous using this chain of then calls. And so there's a question, so is resolve a method? Resolve and reject are functions that are passed in our executor function. So if I just go back you're writing as the programmer to determine when this promise should be resolved. And the conditions for when we would resolve or reject a promise depend on the circumstances of what we're coding, right? So in the pizza example, or in the example that I did in the video, I was waiting until a button had been clicked, essentially, to resolve a promise. There are different cases when we might want to resolve or reject, and one of the biggest uses for promise is what we'll see next week, which is when we want to request data from other servers and put that data somehow onto our web page. So we might, for example, request data from another server, and the server might be down. So we might end up rejecting this promise to get some data and do something else since we don't have that data that we requested. But if we do get it back, then we might resolve and say, use that data and create a new element with some text and throw that on our page. That is one of the biggest uses for promises, and we'll see that next week. But it is a lot to see all at once, especially along with learning about fetching new resources to our page. So we kind of just wanted to motivate its use before we got to that point. And again, resolve and reject are passed in for you. They're automatically passed into your executor function that you define. They're given to you by the browser, by the promise object. Okay, so I know for those of you who watch the videos, I understand that that was a pretty in-depth overview of the slides. So I apologize, but I guarantee you it's good to see it again. And for everybody, even for those who are seeing this for the first time, it's going to take a little bit for this to sink in and to understand promises. This is one of the most confusing parts of JavaScript, not just asynchronous programming, but promises specifically and how they work. So it'll take a little bit, but you will get the hang of it. And so what I want to do now is sort of go over to Ed, and you should be able to see these practice problems. If you go into the lessons, there should be lecture 11 exercises. And I want to go through some simple examples here. So can somebody confirm when they've gotten to this page, if they're on this question? Okay, so why don't we just take a minute and have people just go and answer this question. And what you're basically doing here, what order the log statements printed to the console, you can drag and drop these into any order you want, and then you can submit. And so I'll give everybody about a minute to do this, and then we'll talk a little bit about this before we move on to the next problem. So I'm just waiting here. I can see how many people have opened this problem and how many people are about finished. So about half of the people who have seen this problem have finished. So we'll wait just a little bit longer for people to give an answer. So Jeremy, if you go into, if you click lessons, and you come down here to lecture 11 exercises in week 4, you should get there. And so Aaron, yeah, I'm gonna just give everybody a second here to finish this. And then I will submit this. Okay, so I'm gonna go ahead and answer this. So let's see here. I believe it's pizza ordered, waiting for my pizza. Here's your pizza. Let's submit. Okay, so the correct order here is pizza ordered, waiting for my pizza, and then here's your pizza. And so we can actually go over here, click the preview, and we can see that this occurs. Pizza ordered, waiting for my pizza, here's your pizza. And so, why is this the case? Well, as I was mentioning in the slides, the order executor function gets executed immediately when you create the promise object. So this console log here is invoked immediately when I create my promise object. And then I'm setting a timeout. And I've added a console log. So this will happen. I'll execute the console log once the pizza promise resolves. But then I'm going to call waiting for my pizza. So order executor gets executed immediately. That's why we get pizza ordered. But then we don't resolve for a second. So this is asynchronous. But before this gets resolved, we actually call console.log. So that's why we get this functionality here: pizza ordered, waiting for my pizza, here's your pizza. Does anybody have any questions about that? I'm going to reveal the next problem. Okay, so the next problem is available. So go ahead and take a look at this one. You'll notice it is the same exact thing, except there's no set timeout. So just going back here, practice problem 2, there was a set timeout. We had a second, then we resolved. Here, we're going to resolve immediately. So what is the order here? And I'll give everybody a little bit of time to do this. Why didn't I have to pass a parameter to console log? I'll explain that when I go over this problem. And the same for Aaron and Jeremy. I'll answer your questions once we go over this one. And catch this as we are answering your question as we speak with this problem. Okay, so it looks like the vast majority of people have answered this. So what is this one? So we immediately call pizza ordered. Then we get waiting for my pizza, and here's your pizza. And you'll notice that this is the exact same order as the previous question. Why is that? Why we don't have a set timeout here? So why is this the case? And I'll prove it to you here by clicking the preview. And you can see it's the exact same. And now why is that? So let's think about what would happen if we were to execute this code truly synchronously. So order executor gets called, we call console log, we call resolve. When resolve happens, we then call all of the functions, right, that have been chained using then, right? But if we were to do that, then all of our code would be executing synchronously, right? We wouldn't have any asynchronous benefit to using a promise here, but promises are inherently asynchronous. They allow us to handle code that is asynchronous, and they themselves execute code asynchronously. So when the resolve function occurs, it is a trigger to tell the promise to execute all of these functions that we chained with then. But they don't occur until after we have executed our synchronous code here. So you can almost imagine that there was if it helps you, you can almost imagine that there was a set timeout here. Let's say, where this set timeout occurred immediately after 0 seconds, right? But what this does, without getting too much into it, this kind of puts this code at the end of, in JavaScript, what is known as the call stack. And so what that means is it gets executed after all of this current code executes. regardless of whether or not we have a timer here. And basically under the hood here, resolve is calling these then functions using basically a 0 set timeout. So what the code that we have changed in the then always gets executed asynchronously. Now, there's a question, resolve, Aaron says, so resolve is what happens if your promise is fulfilled. Resolve is actually what we call that makes our promise fulfilled. We don't call that in response to the promise being fulfilled. The promise object itself doesn't have the fulfilled state until we call resolve. So we have to call resolve in order for these functions that we passed in with then to be executed. Why didn't you have to pass a parameter to console log? Because console log automatically takes a parameter, right? So I don't have to do that. The function signature of console log, you can imagine, just has a parameter for a message. So I don't have to do that. I can just pass in console log immediately. You can sort of think about that. I could define my own function that takes a parameter and just reference that by name here as well, and that would log to the console. So you can think if I were to do like function, just print message here, message, and do console.log message, right? I could just replace this with print message and it would do the same thing, but print message has the exact same function signature as console log, so I can just do that. Let's see. Passing a parameter to resolve passes the parameter to then. Yes, it does. So order pizza here, the order executor called resolve with a string with this value. This value gets passed into this then function. So here, which is console log or any other function. And if I were to chain thens, if console log returned something, then that would get passed on to the next function in the then chain, and so on and so forth. And so the question is the same with reject. Yes, exactly. So the same happens with reject. So I can pass in a function with reject, or a value to reject, and that would get be accessible to any on reject handlers I had. So back here, so if I were to reject a promise and pass in a value in my catch function, I would get passed that value into the callback. Can you resolve or reject with multiple parameters for callbacks taking multiple args? That is a fantastic question. I have no idea. So how might we test that? I am just going to go ahead and see if I can pass in another arg. So another argument here. And let's just see what happens here. Let's see if I define a function here that takes just trying to see if this does anything. I think you can only pass in one parameter. I'm not sure. Yeah, so you can see here that even though, and I'm mixing double quotes and single quotes, but even though I passed in 2 arguments into resolve, you can see that the only thing that got passed in to my function here was the first parameter, which is here's your pizza. So you can only pass one value here. Yeah. What would happen if you reject something after you resolve it? You can't change the state after you've resolved. So once it goes resolved, that's it. No takebacks. It's when it's resolved, it's resolved. When it's rejected, it's rejected, and it stays at that state. Can you pass something like an array instead of multiple arguments? You can pass an array. You can pass any value here that you want. And you'll see next week, for example, we'll pass like a response object that we get from requesting data from other servers. But you can do anything. You can pass anything here. I think in the example in the lecture videos, I was passing elements, HTML elements. So you can pass whatever you want here. I'm going to go ahead. Let's go to the next problem here, and then I'll answer some more questions. Okay, so we should be able to go to problem 4. So let's go ahead and take a minute to do this one, and then we'll talk about it and I'll answer some more questions. Okay, about half of people are done here, so we'll take another minute. Okay, seems like a good number of people are done here, so I think people have the hang of this. So what happens if this button isn't clicked within 5 seconds? And it seems here I didn't reveal my button, but I don't think there's supposed to be some HTML here so you could see a button. I forgot to access that tab here, make it visible. But anyways, you can imagine there is a button. And if it isn't resolved, isn't clicked within 5 seconds, you can see here that we will call the reject function. And rejected promises, as Tal said in the chat there, rejected promises get caught by the catch functions that we define here. So in this case, we would print out option B. And I can click the preview here, and I can wait and not click it. And I get option B. Now, there's an extra question here. What if an error occurs in my executor function? Well, let's see here. So instead of all of this code, why don't I just throw an error here? And we can just see what happens. And if I go over to the preview here, you can see it automatically, immediately prints out option B. And I can show you that that did change. I know it didn't look like it, but I'll just immediately resolve, just for the sake of this example, to show that if I resolve, I call option A, right? Okay. And now if I throw an error, then I immediately get option B. So you can see here I've skipped over the function that I defined in then, because I only call these when my promise is resolved. But if my promise is rejected or I throw an error somewhere in my executor code here, then I'm going to go into the catch functions. And as was asked before, can we access or pass values to reject and access them in our catch functions? Yes, we can. And I'll just add a value here, and I will log that out. And you can see that that gets passed into that function as well. OK, so let's go ahead and go on to the next question here. going to reveal problem number 5. And you should be able to get that. In this case, this is a generic error. There are different error types. I'm not actually particularly familiar with throwing different types of errors. Fitz, or do you have more familiarity or practice with that? Typically, we don't. We just specify the generic error. But I'm going to have to get back to you on that, Aman. It's a good question. Okay. Good number of people are trying this. So what happens if the button is clicked after 5 seconds? Okay, almost everybody is done. The correct answer doesn't really match the preview, so let's go ahead and do this. So what happens here if I click the button after 5 seconds? I'm going to do clicked here. And somebody says the preview doesn't match what I did here. It's possible that I may have made a mistake here. These look pretty similar to me. But what I want to see is what happens if the button is clicked after 5 seconds. Okay. So I'm going to wait 5 seconds for this to happen. Okay, I've rejected. I'm going to click here, and we get clicked. Right? So what happens here is sort of what we were saying before. The question was, can we change the state of our promise once we've already determined it? So we rejected it. The status of our promise is rejected. And now, after the fact, we're trying to resolve, and that doesn't work. You can see you can't change the status. Our then function didn't get executed like it would have if we had first resolved this promise. And so I will go ahead and click it, and you can see here that this didn't resolve. Why not? This should have resolved. I'm a little confused now. Let me reload this. I'm going to go down here. I'm going to go to the preview, and I'm going to click this. There we go. I don't know why it didn't work there, but when we first, if we resolve this before it's rejected, then we do get option A out. I was having a little bit of a heart attack there. These little widgets can be a little temperamental sometimes. So anyways, if I reload the page again, if I click this button before it's rejected, I get option A, right? But if I go and wait for this to reject first and then click it, I can't call the chain of functions that would normally be executed when I resolve. And so Kevin says, what are the benefits of using promises? Connor is going to answer this. Some of these examples that I've shown are a little contrived. They're not the best use case for promises, but we'll see that there is a very, very good use case coming up with requesting data from other websites. So making HTTP requests where we definitively want a response one way or the other, resolving with data from the site or failing with a rejection. So we want to be able to handle either case, and promises have this structure built into them that allows us to do this. So let's go on to the next problem, and then I will answer some more questions. Okay, you should be able to access the next problem here. So this is a little example about error or value passing, excuse me, not error passing, value passing. There's a question, do we not get any output from the resolve call after the promise has already been rejected? That's correct. It's not an error, it's just the way that promises work. It is the expectation of a promise that we can't change its state after it has already been resolved or rejected. But yes, you're right. If we reject first and then try to resolve, nothing in that then chain happens, and we don't get any feedback, nothing happens. So let's see here. Okay, it seems like most people are done. So we see here what value is printed to the console. So we create a new promise with Executor, which resolves with 1. 1 gets passed into add. Add just adds 5 to it. So we have 6. It returns that value, which gets passed into multiply. Multiply gets that value and multiplies it by 6. So 6 by 6 is 36. And we just print out that value to the console. And you'll see here, if I just run this in the preview, we get 36. And then I do want to see if we can get to this next problem really quickly. I think it's a good one. We have a minute left, so let's see if we can do this really quickly. It should be available now, and I will answer these questions once people get a chance to look at this. So the question is why, when we rejected problem 5, Rahul, if you want to stay after, and I can go back to problem 5, we can talk about that one. Jeremy, if the resolve reject decision is only made in the first function, what's the point in having the others separate? If you want to stay after, I can ask you a little bit more about that. Oh, this problem answer. Okay, great. So what is the value printed to the console? So we have a new promise here. It calls Executor. It resolves with 1. Right, so this value gets passed into the add function, and then that resolves with the value plus 5. So we actually get 6 here. And we can see that if in the preview. And the whole point of this basically is to say is that these functions we define and then can return promises themselves, right? And then whatever is chained after add in this case has to wait until the promise returned by add is resolved. And so this is one of the really cool benefits of promises, and it makes our asynchronous code look really synchronous. So obviously we're over time, but if you want to stay after and ask questions, be my guest. And then Fitz and I also have office hours right after this. Okay. All right, great.